Hello everyone, this is Akansh Suman here. Now we are going to discuss the basic concept of the centrifugal governor. We have started the new chapter that is governor, and in this topic we will see what is the purpose of the governor and what is the working principle of the governor. First of all, I will tell you what is the aim of the governor, why we use the governor. Basically, it is used to maintain the mean speed of the engine. What is the aim here? I'm just writing because this is important. Just to maintain the mean speed of the engine. Maintain mean speed, or you can say average speed, mean speed of engine. You can say it is used to control the mean speed of the engine. Both the things are same. So why we use governor? Just to maintain the mean speed of the engine. That means this is important from examinations point of view, as well as it is important from interview point of view, because in the interview generally they ask the difference between the governor and the flywheel. What is the flywheel? We will study in the flywheel chapter. So basically, what is the governor aim? That is to maintain the mean speed of the engine. Okay, now we don't apply the governor in the automobile engine. I'm talking about the automobile engine such as the scooter, okay, motorcycle, etc. Because if you apply the governor in the automobile engine, such as if you apply the governor in the scooter, what will happen? I already told you the working principle. What is the working principle of the governor? Again, I'm telling you the working principle of the governor, that as you increase the load on the engine, there will be a variation of the load. Okay, whether you increase or decrease the load on the governor, there will be a variation of the load. So according to the variation of the load, there will be a changes in the mean speed of the engine. So if you apply the governor into the scooter, what will happen? Suddenly you want to apply the brake because somebody has come in front of you. You want to apply the brake, and what will happen? Because governor is going to be applied in the engine, so as you decrease the speed of the scooter, there will be a governor which is just to maintain the mean speed of the engine. Okay, so it will increase your scooter's speed, so there will be accident. If you want to increase the speed of the scooter, because just someone has coming in front of you with a very fast speed, so you want to increase the speed of the vehicle, but there is, as you increase the speed of the vehicle or speed of the scooter, there is a governor which decrease your scooter's speed, because its purpose is to maintain the mean speed of the engine. Its aim is to maintain or control the mean speed of the engine. So that's why we don't apply the governor in the automobile engine. We just use the flywheel. Okay, so we have here there is a diagram, that is the centrifugal governor. We will see the basic concept of the centrifugal governor. First we need to understand the structure constructions of the governor. Here you can see there is a pivot point here P, and there is a two arms which is going to be attached at a pivot point, and these two arms having the fly balls, and these two fly balls are having equal mass. Both are having equal mass and arms of equal length. These two arms are having the equal length on the both the sides. Okay, and this is not arm, this is a link. Basically, why we have used the link here? Because we want to connect the sleeve to the arms. Here you can see sleeve which can move upward and downward. Okay, it can move up, it can move down. Okay, so basically this sleeve is connected to the arms via link. These are the link. I am saying that there is the same length of both the arms on the both the sides, but it may be possibility that arms and link are having equal length. It may be that arms and link are having different length. Both the possibilities are there. Okay, so don't be confused here. Here arms on both the sides are having equal length, but if I'm talking about arms and the link, they may be same length and they may be different length. Okay, so here if I'm talking about the sleeve, you can see sleeve is inserted in the spindle. There is a spindle you can see, which is going to be rotated with an angular velocity omega. Okay, it is in rotation with the angular velocity omega spindle, and this spindle is connected to the bevel gears. Here you can say this is a bevel gears. Okay, and bevel gears is connected to the engine shaft, main engine shaft. Here it is connected to the main engine shaft. So whatever be the changes in the engine, there will be a changes in the governor, because both are connected through the bevel gear. Okay, so if I increase the load on the engine, there will be a variation in the centrifugal governor. And what is the variation, we will see here. See here. Now, since sleeve can move up and downward movement, okay, it can move upward, it can move downward. So as you increase the load on the engine, there will be a decrease in the speed of the sleeve. As there is a decrease in the speed of the sleeve, there will be a downward movement of the sleeve. The sleeve will start move downward. Okay, it will start move downward. So as the sleeve start moving downward directions, since the sleeve is connected to the throttle valve via bell crank lever, it is connected to the throttle valve via bell crank lever, and in the throttle valve we are having fuel. Okay, so as there is an increase in the load on the engine, there will be a decrease in the speed of the sleeve, and it will decrease in the speed of the spindle, and sleeve will start moving downward. And as the sleeve start moving downward, there will be an opening of the throttle valve. The throttle valve start opening, and as there will be a throttle valve start opening, there will be a fuel supply. Okay, as you increase the more and more opening of the throttle valve, more and more fuel will supply. Okay, so when the sleeve hit the bottom stopper, you can see this is the bottom stopper. So as the sleeve hit the bottom stopper, this is the bottom stopper, this is a limit up to which sleeve can move downward. This is the bottom stopper. As the sleeve hit the bottom stopper, the throttle valve fully open. Okay, this is the case when the throttle valve fully open, when the sleeve hit the bottom stopper. Okay, as the throttle valve fully open, that means this is the condition when maximum fuel will supply. And when the maximum fuel will supply, there will be maximum power generation in the engine. Are you getting my point? So we can write it as, in the next page I'm going to write the procedure. When the sleeve, you just need to write in order to understand it properly. When the sleeve of the governor, I hope you are getting my point. When the sleeve of the governor moves down, as it will moving downward, what will happen? Because there is an increase in the load on the engine, so that's why sleeve of the governor will moving downward. So when it is moving downward, there will be a opening of the throttle valve. Okay, throttle valve open, throttle valves open. Okay, it is clear. When the sleeve of the governor move down, throttle valve start opening, and when the sleeve hit the bottom stopper, because the limit of the sleeve of the governor in the moving downward, that is the stopper. So when sleeve hit the bottom stopper, or you can say when the sleeve of the governor hit the bottom stopper, what will happen? Here when sleeve hit the bottom stopper, throttle valve fully open. Yes or no? Throttle valve fully open, and from the throttle valve you can see there is a fuel supply. So that means there will be a maximum fuel supply. And when there is a maximum fuel supply, that means engine develop maximum power. Engine develop maximum power, and sleeve is connected to the throttle valve via bell crank lever. Engine develop maximum power, because governor working principle, aim of the governor is just to maintain the mean speed of the engine. So as you increase the load on the engine, there will be a decrease in the speed of the sleeve, and sleeve will start moving downward. And we governor want to increase the speed of the engine, so that means it will supply more and more fuel through the throttle valve, so it will increase the speed of the sleeve. Okay, so in order to maintain the speed of the engine, so throttle valve fully open and the engine develop maximum power. Now in the next case, see here, in the next case it will start moving upward. So when the sleeve start moving upward and it will hit the, this is basically the top stopper, and sleeve will start moving upward direction and it will hit the, when the sleeve will start moving upward, throttle valve is going to be closed. Okay, because there is always you can see there is a connection between throttle valve and the sleeve. So as you increase the upward movement of the sleeve, or you can say there is an increase of the speed of the engine, there will be a upward movement of the sleeve. Okay, because the governor just want to maintain the speed of the engine, there will be a close of the throttling valve. As the throttle valve is going to be closed, there will be a less fuel supply, and when there will be less fuel supply, there will be a decrease in the power. Okay, so see here, when the sleeve hit the top stopper completely, the throttle valve fully closed, and when the throttle valve fully closed, there will be no fuel supply. That means engine develop minimum power. Are you getting my point? So I am just writing here so that you are able to understand it properly. In the next procedure, I'm saying that when the sleeve of the governor hit the top stopper, when the sleeve of the governor hit the top stopper, throttle valve fully closed. Okay, throttle valve fully closed, because this is a limiting case. When the sleeve of the governor hit the top stopper, it cannot move upward beyond the top stopper, so throttle valve fully closed. As the throttle valve fully closed, there will be a minimum power generation. Yeah, that means engine develop minimum power. So according to the variation on the load on the engine, there will be a variation of the speed of the sleeve. Okay, here you can see sleeve is connected to the arms. That means as the sleeve will start moving upward, there will be a arms changes position like that. Okay, it will changes position, and there will be a fly ball here, and that will be a fly ball here. Okay, because the sleeve will moving upward, so there will be a new position like that. It would be like that. Okay, and you can see there is a rotation of radius of rotation will be increased, r will increase. Okay, and as there is a decrease in the speed of the sleeve, the position will be here. Okay, and here you can say there is a radius of rotation will decrease. So as you increase the speed of the sleeve or decrease the speed of the sleeve, there will be a changes in the radius of rotation of the fly ball. Okay, so that is the basic concept of the governor. Here I'm going to show you one more thing, that types of armor. First is this is basically important from a numerical point of view. So first is I'm writing here open arm type. Open arm, here you can see this is the fly ball. Okay, of having same mass, both are having same mass, and this is the axis of the spindle about which it is going to be rotated, and this is a sleeve, this is a sleeve. Now see here, open arm type means you can see this is the arm which is going to be open. They are not closed to each other, they are open arm. Okay, but if you extend this line, if you extend this line, there will be a pivot point. This is basically numerical point of view. You need to draw, you need to understand what is the pivot point. Radius of rotation, that is small r, and what would be the height. Understand, this is the radius of the governor, and this r denote the radius of the governor, radius of governor. Okay, and where h denotes the height of the governor, and height would be measured from here, measured from pivot point to here. Okay, this is a center of rotation, and this is r is the radius of the governor, and h is the height of the governor. So p is the pivot point here. Now if I'm going to draw the next, that is a closed arm type. How it looks like closed arm type, because questions maybe comes for on the basis of closed arm type. It is of the type of open arm. Okay, so you need to understand, in the open and the closed arm type, we just need to see what is r and what is the height of the governor. Okay, so here you can see when you extend this you will get the height of the governor from here. Now in the closed arm type we will see this is a fly balls on both the sides of the arm, and this is arm you can see, and this is a closed arm type. You can see here the arm are closed to each other, and this is a pivot point P here for one arm, and this is the pivot point for another arm. So this is the point of intersection O. So here I'm going to write O is the point of intersection. So how can you measure the height of the governor? That is important. Point of intersection, basically you need to measure the height of the governor from the point of intersection. Here you can see this is the pivot point, or you can say this is the basically the, here you can see these two are the pivot points P, and this is the point of intersection. This is not a pivot, this is point of intersection O, because we have extended this line. Okay, this is the pivot point where the arm is going to be pivoted. This would be the pivot point, okay, where the arms to be pivoted, and when they are going to be intersect, that would be the point of intersection. Here they are going to be intersect to each other like that. Okay, and this would be the point of intersection. So always we have to measure the height from the point of intersection to the center of rotations, and this is the axis of the spindle about which it is going to be rotated, and this is the sleeve. This is the sleeve. Okay, and here the r would be measured as small r, that is the radius of the governor. Okay, and this is the height of the governor, that is denoted by small h. Okay, so I hope you will be able to understand. This is our sleeve. You can see this is the sleeve. It is used to represent the position of the sleeve. These two are used to represent the position of the sleeve. So this was the basic concept of the centrifugal governor. We have explained it just because of in the numerical questions they will you will have to understand what is r and what is h. Okay, from where we have to measure the height of the governor, that's important. So basically this was the basic concept of the centrifugal governor. In the next we will study about the types of the centrifugal governor, such as Watt governor and the Porter governor and the Proel governor. Okay, so thank you.